Yeah, I kind of have a busy Friday. I have most of my core classes finals on Friday.
Oh, really? Wow,
Yeah.
you're a little late. You go to East, don't you?
Yeah, I do.
Yeah. Everybody else, all my other students this is the last day. In
Really?
fact, I have nothing tomorrow, nothing Friday, nothing Saturday, nothing Sunday. Yeah, this is like it for me.
Huh. Well, my finals start Friday,
Oh,
and then I have chemistry, math, and lit all on Friday.
wow.
And then, yeah.
So Denver schools go a little bit later than Jefferson County or Douglas County schools.
Well, I think they probably start sooner too, though.
Right, yeah. All right, so what do we got here?
Sorry, I have a bunch of stuff on my desk. The things that I wanted to go over were, like, let's see, hold on, sorry. I have a big packet and I'm trying to find the best ones.
Take your time.
Let's work on these ones. I think find all the zeros.
Okay.
F of x equals 50x squared minus 8.
Minus what?
8.
Okay. When you're finding the zeros, always think factoring.
Okay.
What's the first step of factoring? What's the first kind of factor you want to look for?
Probably to factor the 50, right?
Greatest common factor.
Oh, the greatest common factor?
That's always the first thing you want to look for.
Is it 2?
Yeah, it is. And the beauty of finding the greatest common factor is that it leaves something else. What's that called?
The least common...
Difference of perfect squares.
Okay, the difference of a perfect square.
And it's called that because it's the difference, because it's subtraction.
Yeah.
That's a perfect square number, and that's a perfect square number. So it's called the difference of perfect squares because that's exactly what it is. Okay? Now, how does that factor?
That factors, so you need to, it'd be 5x plus
the square root of that.
Yeah, 5x plus 4, and then 5x.
Not 4, it's the square root of that also.
2, I'm just sorry.
And then the other side is just the conjugate. You don't need to do any math once you come up with the first term.
Yeah,
it's just, automatically the conjugate of it. Okay? So if that is f of x, where are the zeros?
The zeros are going to be f. So wait, would you just put 5x minus 2 and 5x plus 2 equal to 0?
Exactly.
Okay.
And the zeros are always in terms of x. So what's x going to be equal to?
X is going to be equal to, let's see, it's going to be, one is going to be 2 over 5, and the other one's going to be negative 2 over 5.
So right. Plus or minus 2/5. Good on that?
Yes.
Okay. Let's go to a new one.
Okay. Let's do this one. It is... Actually, yeah, I think I just want to work on kind of like factoring today. This one's a little bit harder.
Whatever you like, Simon. You're the one that knows best as to what you want to work on.
Let's do 2x to the 4th minus 11x squared plus 9.
Now, that looks like a quartic, right?
Mm-hmm.
And you don't know how to do quartics. They haven't taught you.
Yeah, it's
They haven't even taught you how to do cubics. The only thing you know how to do is quadratics. So this is what I call a quadratic in disguise. In other words, if you were to go over here and let u equal x squared, then what we're really looking at is 2u squared minus 11u plus 9, right?
Mm-hmm.
Now factor that.
That's going to be, what, you multiply it times 9, right? Or it would be 2u.
Do it step by step. The biggest mistake I see students make in factoring is they try to get the answer in one step. Well, it's not a one-step problem. It's a 3 or a 4-step problem.
And I think
First thing, split that up. That's step 1.
2u and u, right?
Next thing, determine both sides.
And it's going to be, hold on, let me think about this. Would it be plus 9 minus 2?
The only way you can produce a plus 9 is if both signs are the same. They either have to be minus minus or plus plus.
Okay.
If one was plus and the other was minus, then this wouldn't be plus 9. That would be minus 9.
Okay.
So when you see a plus sign, that tells you the signs have to be the same. And to figure out what they are, look to the middle term. Since that's negative, they both have to be negative.
Mm-hmm. So would it be minus 9 minus 2?
Well, now the two numbers have to multiply to 9.
Yeah.
Now, that's the one thing you know. It either has to be 3 and 3 or 1 and 9. In other words, again, think about what you're doing when you are factoring a quadratic. You are unmultiplying it to get back to the two linear terms.
Mm-hmm.
Okay? If I had two linear terms multiplied together, this last number comes from multiplying that number by that number. So that's an extremely important thing to keep in mind when you're factoring. In other words, these two numbers have to multiply to 9. So what's the possibility?
Well, then it has to be 3, right? Negative times negative.
There's only two sets of factors. It's either 9 and 1 or 3 and 3.
Wait, but none of those add up.
You're right.
Oh, wait, no, it's going to be 9.
Yes, that one doesn't work.
But 9 and 1 does.
9 and 1 does. Where does the 9 go?
The 9 goes on it's going to be 2u minus 9, and then u minus 1.
Right. And factoring is ultimately a trial and error process.
Mm-hmm.
In other words, you don't know what it is when you start.
Yeah.
All about producing the middle term. And this method that we just did produces the proper middle term. I knew the left term was correct. That's easy. When you split up 2u squared, it's hard to get that wrong. And I knew the right term was correct because I took factors of 9. So the only term that's in question is the middle term. And that's always the way it is when you're factoring. So this little double smiley face test that I do here, you always need to do that, especially on these higher degree of difficulty problems. Okay? Now, we've got it factored correctly, but we've got it in terms of u. So let's go back. We want it in terms of x, right?
Yeah.
So what is it in terms of x?
In terms of x, well,
What's u?
u is, well, 1u is x squared.
Okay, so
So
every time you see u, substitute x squared.
okay, so it'd be 2x squared minus 9. And then it'll be x squared minus 1.
And that would normally be the end of the problem. But the fact is that that's certainly difference of perfect squares. So that factors into x minus 1 times x plus 1, giving you 2 zeros. Now, let's talk about that for a moment. That doesn't look like difference of perfect squares, does it?
No.
Guess what? All these years they've been lying to you. You don't need difference of perfect squares to factor that. What you need is the square root of that, which is the square root of 2x. And the square root of that is 3. So that's how it factors. Even though it's not the difference of perfect squares, you don't need it to be. It just needs to be the difference of squares. And any number is a square. In other words, I can take the square root of 2x squared, and I get that.
Okay.
And that's what a is. And I can take the square root of 9, but to be honest with you, it wouldn't have to be that. Let's say I had this. Guess what? I can factor that into the square root of x minus square root of 7 times square root of x plus square root of 7. Make sure you understand what I'm talking about.
Yeah, I understand.
That is not the difference of perfect squares, but it still factors. In other words, I'm not quite sure why they teach people the word perfect. You don't need the difference of perfect squares. You just need the difference of squares. And you can always factor it by doing what I just did. Square root of x minus the square root of 7 times the conjugate. And that's how I got these two terms. In other words, most people would stop when they got to this. But the fact is that if you're looking for the zeros, well, notice what my zeros are here. Tell me what my zeros are. I got those 4 factors, and they ask you for the zero. So what are the zeros?
Whatever. So it'd be positive, it'll be positive 3 divided by 2 squared. Or it'd be plus or minus 3 divided by 2 squared, right?
Not 2 squared, square root of 2.
Square root of 2, I mean.
Not the same thing.
Yeah.
Okay, and that handles those 2 solutions. What about over here?
That's just going to be plus 1 minus 1. Plus minus 1.
Yeah. So this thing has 4 solutions. And you would expect that. In other words, the most it could possibly have is 4 because it's a quartic. The most solutions a cubic can have is 3. The most solutions a quadratic can have is 2. So when you see a quartic, you're expecting 4 solutions. Even though we solve it kind of like it's a quadratic. In fact, I like to call these quadratics in disguise, because that's what they are. I don't necessarily need to use this u substitution over here. I can factor it directly like that. You see what I've circled?
Yeah.
I could go immediately from this step to that step if I see it.
But that's...
It's a little harder, but once you do it a few times, you get kind of used to it, and you don't have to use the u substitution. Although
Exactly.
there's nothing wrong with the U substitution, and in fact U substitution plays a very important role in all of calculus, all of higher math. So I didn't mind introducing it here, even though maybe you've never seen it before. But you can kind of see what I'm doing. By using U substitution, I turn it into a true quadratic, which I can factor easily, and then go back and resubstitute to get it back into a function of x, not a function of u. And once I do that, now I can see where, gosh, I can factor each of these functions of x. In other words, I can factor that, and I can factor that. To get these 4 factors, which gives me 4 very precise zeros, which are correct. Now, there's only one problem with this answer. We have an irrational denominator right there. So how would you rationalize that answer?
Would you turn it?
In other words, most of math wants you to have rational answers. They don't like irrational denominators.
Yeah.
So you have to rationalize that denominator, and the way you do it is by multiplying top and bottom by the denominator.
Okay.
In other words, you can always multiply a fraction by 1 without changing its value. Well, there's my 1. Okay. Now, what does that give me? Plus or minus 3 root 2 over 2. And that's a much prettier answer because the irrational number is in the numerator, not the denominator. So if this was like a multiple choice final, this would be your answer. This would not. They're not going to give you an answer that has an irrational denominator.
Yeah, okay.
So the only ones you're going to see on the test are that one. If it's not a multiple choice test, then that's the answer you want to give. You probably lose a point for that answer.
Okay.
And of course, plus or minus 1 doesn't need rationalizing. So these are your 4 answers.
So I need to include that squared in the top side or else... Okay, I get it. I did not know that.
Yeah, you need to rationalize denominator, what you need to do. That's the key. Let's talk about that for a second. If I can get this thing up here, hold on. If I had the only thing you have to pay attention to is if you have an irrational denominator, like that. How do I rationalize that? What's the answer?
What you do is you divide it by... Or you move the square to the top and divide it by 2, right?
No, what I would like you to think of is you're multiplying that thing by 1. And the denominator is always whatever the denominator is. Those two are always equal. But that is the number 1. In other words, if I multiply the bottom by root 2, which is what I have to do to rationalize it,
yeah,
way to rationalize it, then I got to multiply the top by root 2. So the final answer is that. So 1 over root 2 turns into root 2 over 2. If I had 1 over root 3, rationalize that.
Sorry, I wasn't paying attention.
Rationalize that.
Would that be 1 over 3?
How would I rationalize it? What's the process for rationalizing? Definitely want to multiply the bottom by the same thing as the irrational denominator.
And then it turns that into a 3.
Well,
and then it wouldn't.
I have to, if I'm multiplying the bottom by this, I have to multiply the top by the same thing.
Yeah.
I can only multiply that thing by 1, and that's 1. Any other number in the numerator does not make it 1. So the numerator's got to be the same as the denominator, and that turns into this. And the difference is that that has a rational denominator. Now, don't ask me why rational denominators are good and irrational denominators are bad, but that's the convention in math. So whenever you have an irrational denominator, like 1 over root 3, you have to rationalize it. And you always rationalize it by multiplying the bottom by the same thing, which means I have to multiply the top by that also. And I get this. In other words, root 3 times root 3 is 3, which is a rational number. It's not irrational.
Yeah, because there's no squared in the bottom.
Yeah, irrational numbers, I mean, it's kind of a complicated definition. And they cannot be written as fractions. I cannot write that as a fraction. I cannot write that as a fraction. Can I write that as a fraction? Yes.
Yeah.
I cannot write that as a fraction. In other words, any radical that does not turn into a whole number is irrational. Square root of 6, square root of 7, square root of 8, all of those are irrational. Square root of 9 is not. That's 3.
All of the, okay, I understand.
Okay. And the two other most important irrational numbers are pi and e. Neither of these can be written as a fraction. All right. What else?
What else? Let's practice another one. 4x to the third, 4x cubed minus 8x squared minus x plus 2.
All right. They have only taught you one method of solving cubics. And that's by grouping. Solving cubics is horrendously difficult. Make that a 1 instead of a 2, and we'd still be here tomorrow trying to solve that. Okay?
Yeah.
The only easy way to solve a cubic is if it can be grouped. And what is required for it to be groupable is if the ratio of those two coefficients is equal to the ratio of these two coefficients. And I mean that coefficient and that. So do you see how I got 4 over negative 8?
Yeah.
And 1, that's a 1, over, negative 1 over 2. Those two ratios are the same. That means we're going to be able to group it. And that's the very first test you have to have. Has to match that test. Otherwise, we can't use grouping. But the thing is that since they have not taught you any other method other than grouping, if they give you a cubic, you can bet your bottom dollar that you're going to be able to solve it by grouping. Now, how do I group it? Well, I want to put parentheses around that, and I want to put parentheses around that. But I can't just put parentheses around the second two terms. Notice that I've changed it. The secret is to never change it. When you're trying to solve this by grouping, make sure that from step to step you do not change it. For example, this has to be x minus 2. Otherwise, I change it.
Mm-hmm.
You see why? In other words, if you remove the parentheses, you get back to what you started with. That's always the key. Always make sure you get back. In other words, you never want to change it from line to line. Now, factor out a greatest common factor of that term.
Factor out the greatest, it's 2. No, it's 4.
Or what?
4x squared.
That's the greatest common factor. Leaving what?
Leaving, it's going to be x and 2. X minus 2.
Right. Now notice what we're looking at. And this is tough because you're not used to doing this.
No.
Most of your life, you've only factored out, when somebody says factor out the greatest common factor, usually it's a monomial term like that. But in this case, that's not what it's going to be. We're going to factor out a binomial term. We can factor out that from this expression. What's left?
It's going to be, well, would you factor out the x squared, or the 4x squared, I mean?
When you factor out a greatest common factor, what you're doing is dividing each term by that.
Oh, okay.
That's exactly what you're doing. So when I say what's left, it means what do you get when you divide that term by x minus 2?
Do you just get that term by x minus 2? Do you just get...
You get that.
Well, did the x minus 2's cancel out?
Yeah. So you get 4.
That's it? So the x minus 2...
Minus 1.
Yeah, I was unsure about that.
Well, notice why. In other words, if you're unsure about this, let's multiply these two terms back together again. Well, what do I get? I get 4x squared minus x minus 8x squared plus 2, which is, it's 4x cubed minus x minus 8x squared plus 2. Okay? Well, that turns into 4x cubed minus 8x squared minus x plus 2. That should be what we started with. And it is. 4x cubed minus 8x squared minus x plus 2.
So then we're just going to...
After I have factored it, I can multiply it back together again to make sure that I have not made a mistake. You know, if your life depended on it, you'd do that.
So it would...
If to you, your answer depends on your life, or your life depends on your answer, you're going to make sure that when you multiply that times that, you get what you started with.
Okay.
Now, we're not quite done.
Yeah, because we have to find the zeros of them.
Well, I can still factor more. In other words, I've got it down to x minus 2 times this. I can't factor a linear factor any further down. But what is this called?
What does that factor out to?
Well, what's it called, first of all? It's important you recognize the names of these things.
2 squares.
Difference of perfect squares.
Perfect squares.
Even though we have just learned that it doesn't require perfect squares, But certainly, if it is perfect squares, you can definitely use it. So how does that factor? What's the square root of that?
Yeah, it's going to be 2x plus 1 and 2x minus 1.
And those are my three linear factors. And so x equals 2, or x equals plus or minus 1. And those are your three zeros. And that fits perfectly with the problem because it's a cubic. You expect to find three zeros. Now, you're not always going to find three real zeros. Sometimes you'll find one real zero and two complex, imaginary ones. But you're almost always going to find exactly three zeros for a cubic. If you have a quartic, you'll find four zeros. If you have a quadratic, you'll find two zeros.
Mm-hmm.
All right. What else?
Let's do this one. 8 plus or minus the square root of 50. All of that divided by 14.
What do they want?
Oh, sorry. They just want to simplify.
Okay. Just as a note, that looks an awful lot like an answer you would get from applying the quadratic formula, right?
Yeah.
And it is. That's how they got it. But I can still simplify it. I can simplify every term here. Always start there.
Divided by 2.
How does that simplify?
That simplifies into that's what? 20. Can we do 25 and 2?
Okay, so what does it simplify to?
So plus so it'd be 8 plus minus 2 square root of 25. 2 times the square root of 25.
All right, here's the way you want to do this. Here's the way you want to do this. Do it like this, always. Now that turns into a whole number.
And then that'll be, so it'll be 5.
5 root 2.
Okay, 5 root 2.
Okay?
Yeah.
And now it doesn't simplify too much anymore. In other words, I'm still dividing all that by 14. And normally it looked like I could have divided top and bottom by 2, but I no longer can. Because 5 is not divisible by 2.
Yeah.
So that would be my final answer.
That's it?
Yep. Now, if this was like a 6, well then I could divide top and bottom by 2, and I would have 4 plus or minus 3 root 2 all over 7. But it wasn't. It was a 5. It came out to be 5. And 5 is not divisible by an even number that goes into 8 or 14.
Yeah.
So I would leave the answer exactly like that.
Okay, so next then?
Okay.
Okay, so let's simplify the following. Actually, no. Let's rewrite it in Vertex form, and it's y equals 3x squared plus 24x plus 7.
The key on all problems like this is to know the general format. What's the general format in Vertex form? In other words, there's a few general formats for a quadratic. The most important one is Vertex form. What is it?
The general form or Vertex form?
general for the vertex form.
Is that the one where it's parentheses x or a b, a and then x and then squared plus?
The reason that's called vertex form is because you're staring at the vertex. H and K is the vertex.
Mm-hmm.
So
Okay.
if you're going to graph a parabola, absolutely the most important part you can start with is the vertex, right? A lot of people would say that's the 90% the most important part of any parabola is the vertex. So this vertex form is huge. Okay? Now, what we have to do is take that equation and put it into this format. Okay? And it involves completing the square. So I'm going to have to put parentheses around that. So the first thing I'm going to do is rewrite it like this. And put that 7 way out to the right like that. Now, again, notice I have not changed anything. Always extremely important that you not change it when you go from step to step.
Yeah.
Now, you cannot complete the square until this coefficient is 1. That's just the rules.
Okay.
So if that coefficient is not 1, you have to factor it out. So what's the next line?
So then it's going to be, well, we have to get that equal to 1, so...
Hold on. You just have to factor out the 3. That's all you have to do.
That's it? So then it would be y equals 3, and then parentheses x squared plus 8x.
That's all you have to do. In other words, the goal is make sure you do not change anything. That line is the same as that line is the same as that line.
Okay.
Now, I'm getting closer to being able to complete the square. So how do I complete the square inside the parentheses?
Do you have to factor out an x?
No, it's not the way you complete the square. You complete the square by taking half of the coefficient of the x term, squaring it.
Yeah. Squaring the coefficient of the x term?
Coefficient of the x term is 8. I'm going to take half of 8, which is 4. I'm going to square it, and I'm going to write a 16 right there.
16, okay.
Now I just changed the equation significantly when I wrote that 16 there. I got to balance it. In other words, I do not want to change this equation from row to row.
And then don't you have to add 16 to 7?
Not 16. First of all, I'm on the same side of the equation. So if anything, I got to subtract. But
16.
It's not 16. When I wrote 16 there, how much did I add to the right side of the equation?
Oh, you added, oh, you need to multiply 3 by 16.
Exactly. I added 48.
48,
So
okay.
I got to subtract 48. Now, what I've written is the same. Always remember the goal. The goal is to not change anything from there to there. Could I take this answer and get back to my previous row? Yes, very easily, by erasing the 16 and erasing the minus 48. Then I'm back to what I have on the previous line. Okay? But there's a reason we're manipulating it. We're trying to get it into this y equals a times x minus h squared. Well, because you completed the square, that always allows you to write that quadratic in terms of a linear term squared. What linear term is that squared?
That linear term is x plus, would it be, oh god, it's going to be 4?
Yep, whatever you got when you took half of that.
Okay,
That's
yeah.
what it is, always.
And then it's going to be minus 41.
Now, look what we have. We have it in perfect. Y equals a times x minus h squared plus k. So tell me what the vertex is.
The vertex is going to be 4.
What's h?
4.
H is the x coordinate. First of all, the vertex is a point, so you need an x and a y coordinate.
Oh, yeah. It's going to be, well, the y is going to be 4, right?
No? H is the x coordinate, k is the y coordinate. So tell me what h is.
4 minus 41. Or 4.
First of all, h isn't 4. If h were 4, this would read x minus 4. It doesn't. It reads x plus 4. So what is h?
H is, okay, I'm sorry. H is 4, though.
No, it's not. If h was 4, then I would have x minus 4 squared. I don't.
So then
I have x plus 4 squared. So h has to be minus 4.
Oh, yeah, it's always the opposite.
Yeah. What's k?
And then k is just regular 41.
Negative
So
41.
That
negative
is a
41. Plus k. So if that's a negative 41, then the y-coordinate of the vertex is negative 41.
I feel dumb because I remembered that.
It's all right. No, don't feel dumb at all, ever. Remember what we're trying to do here. We're trying to put it into the general format, and then once you have it in the general format, you have to figure out what h and k are.
Yeah.
And h is always the opposite of that sign, and k is always that, including the sign. If that's a plus 41, then k is plus 41. If that's a minus 41, then k is minus 41. And now we have the vertex. I think that's all they ask for, isn't it?
Yeah, that's it.
Okay. But notice that there's actually 2 ways to get the vertex. This is perhaps the best way, is to put it into vertex format.
Yeah, and then I think I was doing something with my friend yesterday, and he said that you could
there's the easy
multiply.
There's the x coordinate of the vertex right there, minus b over 2a. Notice what that's minus 24 over 6. That's minus 4. That's just what we took 15 minutes coming up with. Okay.
But then you don't have the 41.
Problem is that does not give you the y coordinate. It just gives you the x coordinate. If you want to get the y coordinate, you got to plug in minus 4 into the equation and figure out what you get. Well, you get 3 times 16, 48, minus 96 plus 7.
So maybe it would take around the same amount of time in this scenario.
Not necessarily. I can come up with that pretty quickly. That's minus 48 plus 7. That's minus 41. So I figured out the x-coordinate and the y-coordinate probably in half the time that it took me to do it by putting it into vertex format. Because putting it into vertex format, you got to go through that completing the square process. And that's not the easiest process, especially with this problem. Because we have a coefficient there, so we had to factor it out. Then we had to complete the square, and then we had to know that the term that we had to balance it is not with 16, it's 3 times 16. So there's lots of mistakes that can be made by trying to solve this by putting it into vertex format. It's really easy to make a mistake. Whereas if I use x equal minus b over 2a, I'm getting the x-coordinate pretty easily. Then I just have to plug that into the original function to get the y-coordinate. So my personal preference would be this method over here. I can always do that quicker than somebody else can complete the square. But in this problem, the instructions were very specific. Solve it by completing the square. So they didn't really give us any choice. We had to get it into vertex format.
Yeah. Okay. Ready for another one?
Yeah, hold on. Let me just make sure I'm on the right time frame here. This is my last day. I'm so excited.
Okay.
Not to say that I wouldn't be happy to tutor tomorrow or the next day or the day after that. It's just I've been busting my ass for 3 weeks here. I've been booked almost solid every night.
Yeah, I bet for finals.
And boy, at this time of year, I am so happy I'm down to the last day. Now, 3 days from now, I'll be miserable because I got nothing to do.
Yeah, exactly.
That's the truth, the solid truth. I love tutoring. If I had my druthers, I would say, give me a tutoring session every day of the year, including Christmas. That's what would make me the happiest.
Yeah.
All right. So what else? What else do you got that we can do in 8 minutes?
I think we can run through this one in 8 minutes.
Okay.
6x squared over x squared minus 16, and then all that minus 3x divided by x plus 4 equals 4 divided by x minus 4.
2 ways to do this problem. One is to operate on the left side of the equation and find a common denominator and proceed from there.
Mm-hmm.
What would the common denominator be if I were to do that?
X plus 4, x minus 4.
Okay. There's actually a slightly better way that is kind of one of my favorite methods, which is to try to eliminate all 3 denominators in one step. Well, if I multiply all 3 parts of this equation by the common denominator, which is that,
Then it gets rid of all the denominators.
it gets rid of everything, and you're left with nothing but numerators. So it becomes 6x squared minus what?
6x squared minus 3x, x minus 4.
Yeah, don't be afraid to write it piecemeal like this. That's the best way to do it, really.
Oh, yeah.
Equals 4 times what?
Equals 4 times x plus 4.
Now simplify it. That way you don't make any mistakes. You try to do, I find that a lot of my students try to do 2 or 3 steps in one, and that leads to mistakes. If you just write it out and then simplify, it's always the best way. What's the next term?
The next term would be equals x.
Hold on. I haven't multiplied that by that yet.
Oh, sorry. And then that'll be positive 12x.
The reason I asked.
12x. And then equals 4x plus 16.
Now, it's a really easy equation. Nothing hard about that at all. Algebra 1 first month student could solve that.
Yeah.
It was only hard when we had denominators. So I tell everybody, get rid of your denominator if you can, always. Now I'm going to combine like terms. I'm going to put my x's all on the left side, and I'm going to put my numbers all on the left side, because when I have a quadratic that has both an x squared, an x, and a number, I know I have to set it equal to 0 to solve it.
Yeah.
I don't want that 16 on the right side. I cannot solve it if I leave that 16 on the right side. And that's kind of what everybody's first inclination is to make the 16 on the right side and then try to factor out an x or something, but it does not lead to the solution, trust me. Okay? So, now we have it as a quadratic. There's no greatest common factor that I can take out. So let's see if we can factor it.
So it's 3x and x.
Okay. What are both signs?
48.
Both signs. That's all I want.
Oh, both signs. Doesn't it has to be negative? Isn't it like
They have to be opposite.
Okay, so it's gonna be a plus and a minus.
That's probably the most important realization you can make in factoring.
So is it
the second step, which is to figure out both signs. So I know it's either plus minus, but in this case it might be minus plus, and they're not the same because this coefficient is 3, this coefficient is 1. So plus minus is not the same as minus plus. So I have to allow for both. Now I just have to play around with factors of 16.
Which is, so it's 4 and 4.
There's 16 and 1, there's 8 and 2, and there's 4 and 4. That's it. And what I generally tell people is try the two that are closest together first.
So
we are definitely in a trial and error process here. There is no algorithm that I know of other than trial and error. I'm going to try these factors, and I'm always going to try the two factors that are closest together. Okay, well, let's just start with 4 there.
I think there is one method where you don't have to use trial and error.
Yeah, you might be right, but it's so complicated and confusing that nobody, including myself, can remember.
Yeah, and actually, I think it actually still does.
And trial and error works fine. Trust me.
Yeah.
There's nothing wrong with trial and error. First of all, does this work?
Yeah, it's going to be plus 4 minus 4.
Oh, it's going to be plus 4x, and it's going to be minus 12x. In other words, you have to do the insides and the outsides.
And that,
together, that gives you minus 8x. That is not our middle term. That is not our answer.
It's minus 4x.
There you go. In other words, if you get the right number but the wrong sign, then the only thing you have to do is move that 4 down to there, that 4 down to there. And now, when you check the middle terms, you'll get minus 4x and plus 12x, which turns into plus 8x, which is our middle term. So we know we've done it correctly. But this little check, especially when you're dealing with these kind of quadratics, when you're dealing with a quadratic that has a coefficient other than 1, that's a higher level quadratic. And that's what I call trial and error quadratics.
Yeah.
That you pretty much have to just do trial and error until you produce the proper middle term. And I didn't have any reason to start with 4 and 4 other than in the state of Colorado, most quadratics they give you that can be factored factor into the two factors that are the closest together. So always start there. If 4 and 4 didn't produce a solution, then I'm going to try 8 and 2. If that didn't produce a solution, then I'm going to try 16 and 1. And I'm just going to keep playing around with it until I'm able to produce that middle term. That's always the term in question. Diamond?
Yes?
This is our last session, right?
For now?
Okay, I meant for this year. Yeah, maybe not. Since your test isn't until next week, you might want to schedule something. Please do. I am totally wide open, as you can see. I got nothing Thursday, Friday, Saturday, or Sunday. So if you want to schedule a session, I'm completely available. But
well, my test is Friday.
Your test is Friday? Okay, so So probably this is our last session. You had one scheduled tomorrow, which you canceled, so I'm presuming you don't want one tomorrow.
No, I have to. I'm gonna go in after school and talk to my math teacher. I need to.
Okay. So this is probably our last session for the school year, and you have a good summer. And do you know what kind of math you're taking next year?
Honors pre-calc.
Cool. Love it. Happy to work with you. You're one of my few students. Most of my students are taking stats, which
Really?
I don't tutor stats. Yeah. So, well, actually, all my pre-calc students are taking stats next year, which means I don't get to work with them. But you're going into pre-calc, and I can definitely help you with pre-calc and calc.
Yes. Okay.
Okay? So,
Well,
have a good summer. And I do actually do tutoring in the summer. I do it for 20 bucks an hour instead of $32 an hour. So if you want to get a head start on pre-calc and you want to do like a half an hour every other week or something just to avoid slippage, not a bad idea. Most students undergo a lot of slippage when they go 3 months without taking math.
mm-hmm.
Just do. It's a natural thing. You're just going to lose a lot of what you learn.
Well, I think I'm gonna have to take some more. Well, I'm gonna be out of the country most of the summer, so.
Oh, okay. Where are you going? Sounds like
I'm
fun.
going Argentina.
Wow, I don't know what that sounds like. Oh, no, Argentina's not Venezuela. Venezuela's the one that's falling apart.
Yeah, exactly.
Yeah, okay. Well, good.
Well,
That sounds like fun. Enjoy it.
I will, and I'll probably. I don't know. I think I'll get an appointment with you when I come back because it'll be a good refresher.
Yeah, for sure.
Okay.
All right, Simon. Have a good summer, and I will talk to you next school year.
Take it easy.
All right, bye-bye.